problem that we're trying to solve at a really, really, really high level is that as an automotive buyer, it's surprisingly painful to actually find the right part for my car. I was actually at a shop this morning and struggled even just finding the right type of light to replace an indicator light.
Yeah, so our customers are kind of anyone involved in the part supply chain. So that can be anyone from original manufacturers of parts, vehicle manufacturers who obviously sell replacement parts for the vehicles they make, original part suppliers, aftermarket part suppliers, people who are sort of copying OEM parts, or they're trying to make something that's higher quality or lower price, whatever it is. Performance, so that's things that are sort of upgrade parts. And then that can be retailers, marketplaces, wholesalers, and even buyers of parts, like insurance companies. So,
Right.
the industry is very non-standardized. It's very large and very fragmented. So there's at least 30,000 part manufacturing brands. They all have their own ways of describing parts, describing fitment information, and it's very hard to capture all the sort of differences in between all these different vehicles. So there's millions of real-world vehicle configurations out there on the road. Vehicles that can sound very similar can actually be very, very different. So 2010 Toyota Corolla could be, hundreds of different real-world configurations with slightly different parts on them, depending on the body style, where it was manufactured, emission standards in various countries, trim levels, and all sorts of other things. And that makes it a very sparse network of connections between these parts and these vehicles, and we have to be able to do that really accurately to sell them online. So we have to be able to say, this is your vehicle. That's the first hard problem. How do we make sure we figure out exactly what someone's vehicle is, and then there's the exact parts that you need for your vehicle. There's a few different pieces to this. There's engineering and infrastructure pieces, and then there's the data pieces. So engineering and infrastructure really comes in because of the scale of the data that we work with here. Everything has to be built for really large scale just to function at all, and then we want to do this real time, really good online buying experiences, so things need to be really fast as well as really scalable. So that presents a lot of really challenging engineering pieces, particularly around the cardinality of data. You can have a single part could fit thousands and thousands of different, or even millions of different vehicle configurations, depending how common or unique that part is. The filtering, aggregation, and storage of all these things presents a lot of really interesting challenges. Then on the data side, as I say, we're working with data in all sorts of different structures. It can be completely unstructured, sort of text information, semi-structured, or somewhat standardized, depending on the supplier and the brand of the parts, etc. And so we have to figure out a way to unify this across the entire industry, so that we can pull it into our system, and then we can really leverage the fact that we have this global standard for how to describe these things. So there's a lot of data science work that goes into building tools and designing algorithms and models that can actually help us do this at scale, because the scale here is far too large to do manually, one by one.
And I'll talk about the engineering component. We've got these relationships, we represent the data as a bunch of relationships between what we think of as a part, and then what sellers are trying to sell, and what buyers are trying to find, and what they're actually trying to fit it to a car. A lot of these relationships are many to many, which, familiarity with databases, there's certain ways you represent that. But because there's these layers of many to many-ness, when we go and get some upstream system go and change one of them, and this could be, we change what the definition of a vehicle is in a country, all of a sudden you have that one vehicle impacts 10,000 parts that we know fit that vehicle. So all of them suddenly change a little bit. And then those 10,000 parts are sold by, it could be a smaller number of sellers, but they each have like 50 products for the same physical part. And all of those change. And then they're potentially trying to sell on their own website, on eBay, on Amazon. And so you can have this one person go and change this definition of a vehicle, and all of a sudden we've got like 2 million updates to these different external parties to us that we've got to make. very quickly because at that point it's actually incorrect. So designing systems which do that, which do it fairly, when you've got lots of people trying to do.
So Partly finds itself in a unique position where we have a view of data coming from various different data sources simultaneously, whether that's a manufacturer, whether it's a fitter, a person who is actually taking apart a mechanic, putting it inside a vehicle, running a shop and selling some things, or whether it's a website somewhere reporting that a certain part fits into a certain vehicle. What Partly does is we take this disparate data source landscape and we standardize it into a format where you, as a person who is interested in using our product to find the right part, are able to get to the information that you need at the right time. In some cases we deal with malicious compliance, where a manufacturer does not provide us with data in a format that we can easily work with intentionally, so they're complying with the law but not giving us anything that's particularly useful. In some cases the information is just outright unavailable, unknown to anyone, and whether a part fits or not is some secret knowledge that a mechanic has that no one else is going to have access to. It's up to us as the data team in Partly to predict those missing pieces of information, to find those missing pieces of information wherever they may be hidden, and to build a reliable data set for you to be able to use.
So what it means to kind of meet our customers where they are. A lot of the times my team deals with these more complex customers. They're customers who they have experience in this industry. They have data systems that they use to manage their parts, to manage their products, and to manage their day-to-day business operations. A lot of why it becomes difficult is each of these customers, they have a different setup that works for them. And so the difficulty is really in this generalization. How do we not solve it for just one customer, but how do we solve it for a bunch of different customers that might have this setup? Similarly, as the customers get larger, they might have really deep integrated tech stacks. How can we basically get inside of that ecosystem and provide value in a way that doesn't require a lot of bespoke work, but also doesn't require a lot of interruption to them?
It is very rich data set with very big depth of relationships, which means we have a big problem to denormalize the data, to present it fast. Also, the complexity comes with partly moving fast. People need to understand each other and go write code and do it right first time, because there is no time to rework, although we need to do rework because we're also learning. The data be not complete, where a lot of things is extracted from unstructured data where the data science is applied. This is a difficulty on its own. From the system point of view, all of the components of the system are involved. Machine learning is connected to the platform, the input channels connected to the platform, output is connected, and all of that goes in real time with load, sometimes with high load, and it all needs to be processed and go through.